Hi guys. So in this video, I'm actually just going to give you an overview of the whole system I've designed, because the other two videos I just jumped straight in without any context. So what you can see on the screen here is a block diagram I've drawn of the system as it stands at the moment. Now everything in the dotted line is the SoC, which I've called Saber. And that incorporates my Tribeca CPU, and then a hub as well. Now, I built a board for this as well. This is all, the SoC is implemented on a Cyclone 2 FPGA, and I built a board for it, which you'll see in a minute, and you'll actually see it working as well. The SoC has 5 SPI masters on it, an SRAM controller, an LCD controller, and a UART, and then it's got a reset pin and a little bootstrap interface, which is just another 2 general purpose inputs actually. But the level 0 bootloader looks at their state, and when it comes out of reset to determine how you want to proceed with the boot. Now, the Tribeca CPU is connected to the hub through a sort of 32-bit wide read-write data address interface, and then this purple line here is a 4-bit wide hardware interrupt interface. So there are 4 hardware interrupts, and any one of these guys, well, to which interrupts are useful. So for example, the UART for when data is coming in can interrupt the can trigger a hardware interrupt. Oh, actually, what I haven't drawn on the block diagram is the hub has also got some internal timers. So for example, you can configure a timer to generate an interrupt every however often you want, and I actually set up one of those timers to generate an interrupt with a tick to be used by the scheduler. So I haven't actually put those in, which is silly. Anyway, so 5 SPI masters, because I'm actually using the SD cards in SPI mode, so I've got 2 SPI bus masters for those, 1 for each of those, and then the others are connected, as you can see. So SPI 0 is connected to the boot flash, and if you want to boot from SPI, it'll always look for a boot flash on SPI 0. 1 is connected to a mezzanine connector, which you'll see in a bit, and the bootstrap interface is just connected to 2 dip switches. The reset line is connected to a push button. The UART goes to an FTDI USB UART chip, and then we've got the LCD controller, and then SPI master for the touch panel ADC, and then the SRAM controller, which is just connected to the SRAM directly. Okay, so now I'm going to show you the layout, and then I'm going to show you the board, and then you'll see the board working. Okay, so this is the board that I made, the application specific board that I made for my system on chip, which I've called Saber, and Saber contains the Tribeca CPU. So this is the FPGA in the middle here, which I've used a Cyclone 2 FPGA. I have got a micro SD card cage, which I can't actually use because I messed up the footprint for it. The footprint's fine, but the card actually goes in from this side, and also I can't solder it to the board. It was an oversight, because everything's underneath the cage, and it's a nightmare. Everything about it's just bad. And then this is a full-sized SD card cage, which is on the back of the board, and both of them, neither of them use SDIO. They both use SPI mode for data transactions. This is the SRAM here. This is an FTDI UART chip, and here is a micro B USB socket. This here is a 6-pin connector, which has SPI going to it, one of the system on chip SPI interfaces, and that's so that you can plug a mezzanine board into the top here, which sort of horseshoes around the LCD panel here, which is which plugs into that this connector here, and it's a Terasic LT24 LCD touch panel. This is the FPGA. This is the SoC's SPI boot ROM, and at the moment that actually contains the entire operating system. And here is these are two little switches, so you can select the boot mode. So it'll do SPI boot if you select a particular switch configuration on here. Otherwise, it'll force UART boot. If it doesn't find a valid image in here and it's set for SPI boot, then it'll actually fall back and do UART boot anyway from this UART here. This is the Altera JTAG header. These two guys here are the FPGA configuration flash ROM footprints, and only one of them is actually fitted at a time. This is for an Altera specific one, and this is because I hope to use just a normal SPI flash device without it being a sort of Altera specific configuration ROM. This is the 25 MHz reference oscillator for the SoC, and these three supplies guys here, groups of components, are the 3 switch mode power supplies. So I've got 2 3v3s and a 1v2. And this here is the reset button. This is how the layers work. So on the top layer here, this is where I've done most of my routing, and so immediately underneath is a continuous ground plane for an impedance reference. And on layer 3, we've got the power planes here in blue. And then on layer 4, we have got all the remaining routing, anything that couldn't be routed on the surface. So this is the board in the flesh. Building it was a nightmare. It took an entire day. This is the footprint for the micro SD, which I can't use. And then I've actually socketed all of the flash devices just so that I can replace them. So yeah, this is pretty self-explanatory really. There's the JTAG header and the sort of horseshoe mezzanine header, FTDI chip and micro USB socket. These are the power supplies. Here's the FPGA. Sorry about the focusing. My phone camera's not very good. And then over here is the reset button, and this is the LT24 LCD panel header. So the LCD panel just kind of plugs in here. The software doesn't actually use it yet, but you can see that when you plug it in, it kind of sits nicely in the middle there. And on the bottom, I've got the SD card cage here. So let's plug it in. Oh, ignore this monstrosity over here. This is I've actually bodged the Altera configuration flash onto an IC socket to plug it into this other socket. So that's why it looks ridiculous. It does seem to work. And then this is the this is quite a nice little connector actually for the SD card. Anyway, so let's plug it in here. If I can do this with one hand, there we go. Okay, so that's my computer finding the COM port, and that is the configuration done LED. And then if I connect to it here, actually I will have to right. Okay. So it usually comes up from COM5. Yep, looks like it has. And then you can see if I press the reset button here, there we go. The system has booted straight from the flash. So
at the very top, you can see this is the level 0 bootloader's message now. It's telling you it's booting from SPI, and it's found an image, it's copying to RAM and branches to the code, and so now this is just the normal boot. And I'm now going to talk in more detail about how the operating system actually works. So yeah, that's there it is, and it all seems to work, which is great.